Alright, in this video we're going to be looking at some examples from the graphical relationships lesson. Our whole plan here is to try to relate the graph of a function and turn it into the graph of that function's derivative. And if we're going to go ahead and do this, when we're trying to sketch the graph of a derivative from the graph of a function, we're going to use these three steps kind of right here. We're going to identify the approximate slope of the graph at a particular x value. We'll plot that slope as the value of the derivative for that x value. And then we're going to repeat that process until we've plotted enough points that we can reasonably draw a sketch of the derivative. So let's look at example 1 here. We've got the graph of this function. And the first thing I always look for when I'm trying to sketch the graph of a derivative from a function is I look for places where the slope of the curve appears to be 0. And that's the case right here and right here. And so since the slope of the curve is 0 at those points, I'm going to plot the value of the derivative as 0 at those points. I'm going to plot at -3, I'm going to put a 0. And at +1, I'm going to put a 0. And now I'm going to look at what happens in between those two zeros and what happens outside of those two zeros. And if you look at the initial curve between where those two zeros occur, you can see that the slope is negative on the entire interval, and the slope appears to be its steepest, right about here, about halfway in between those 2 points. And if I look at the contour of the curve here, that slope appears to be pretty close to -1. Again, we're sketching here, so it's not like we're going to be exactly precise, but it looks like the slope is about -1 in between those. And if you look at what happened, the curve was smooth in between those. So the contour of our derivative it's basically just going to gradually decrease, get closer and closer to -1, and then gradually increase and get closer and closer to 0 again. And so I'm just going to draw a curve that kind of matches that behavior. And now I have a basic sketch of the derivative between -3 and 1. Now I'm going to go outside of here, and as we move to the right of that 0, we see that the value of the derivative or the value of the slope is increasing. Maybe right about here, the slope appears to be about 1/2. And right about here, it appears to be about 1. And so I'm going to plot slopes. Got a little bit far to the right there with that point. Right about here, it appears to be about 1/2. And about here, it appears to be 1. Somewhere in that neighborhood. And as I move up the curve, the slope gets steeper. And right about this interval, it appears the slope is around 2. So it's starting to level off as we get out here. It's about 2 right in this neighborhood, and it's starting to level off. So it probably looks something like this. And again, like I said, this is a sketch, so realize that we're not exactly precise in doing this. We're just kind of getting close. The slope here, down at this left end, appears to be around 5, maybe, between 4 and 5. And in order to get there, it looked like the slope was pretty much decreasing from 5 to 0 at a fairly uniform rate. So, draw the curve in, fairly uniform in there. And there's a reasonable sketch of the derivative based on this first graph. Alright, let's go on to example 2. Alright, in example 2, we have an oscillating situation. We've got a lot of zeros. Got a 0 here, and a 0 here, and a 0 here, and a 0 here. So I'm going to go ahead and plot all those 0 values for the derivative. And in between them, for instance, in between these two, the slope reaches its highest value right around here. And it looks like that's somewhere between 2 and 3, so I'm going to plot that somewhere between 2 and 3. And I'll go right around 2.5. And if we look at the next interval, in here, looks like it's about the same except a negative value instead. So we'll go down to about -2.5 there. And about the same in the next interval. Looks like that. And then we have these arrows going off the end. So that means that my slope is going to continue to decrease going off this end. But it does so at a kind of reduced rate. I'm going to say right around here, the slope is, around that same -2.5 area. And then it starts to level out. So we'll put it at about -2.5 here, and we'll let it level out. And the same thing over on the left end. Slopes around -2, -2.5-ish out here, and it starts to level off. And now it's a matter of just kind of sketching a smooth curve. Connecting these points. And this curve, since the original curve oscillates between -3 and 3, this curve should also kind of oscillate between -3 and 3. And it might look something like that. Again, this is a sketch, so it's not completely precise, but we want to get close enough that we get a decent idea graphically what's going on with the function. Alright, we'll be a little bit more precise in our last one because we have some easy to read slopes. If we look at example 3 here, this is all line segments based in this sketch. I don't actually see a slope of 0 anywhere, so I can't use that technique. But I'm going to just go ahead and break this down piece by piece. This first piece, the x is -5 to -3, has a slope of 2. And at -3, the slope changes. So I'm going to have a discontinuity in my derivative graph there. But to the left of that point, the slope is always 2. And now I'm going to go over to the right end. That right there has a slope of -3/2, and the arrow indicates that it continues in that fashion. So again, I'm going to have a discontinuity at x equals 3, but everywhere to the right of that has a slope of -3/2. And now I'm going to identify the slopes for the other segments as well. This segment, from -3 to -1, has a slope of 1/2. So I'm going to plot a slope of 1/2 everywhere between -3 and -1. And then I'm going to look at the next segment. This one has a slope of -5/2 between -1 and 1. So -5/2. Go ahead and plot that in there. And then the last segment that we're looking at, this segment right here, has a slope of +3. So I'm going to go ahead and plot a segment of +3. And this is the sketch of the derivative of this function. Notice at all the values where we have these hard corners, there's no value for the function on my derivative, and that's because the function is what we call non-differentiable at those points. The derivative does not exist at those points. But we'll talk about that more in a later video. Okay, so that was how we sketch graphs of derivatives from graphs of functions. And hope you enjoyed it, and see you next time.